Now, these previous building model, this 3 degree of freedom system, we can idealize as a stick model, which I have discussed earlier also in the numerical methods class, but let me quickly repeat so that the whole thing I can present to you in compact form and you can brush up your memory and memory or understanding, I should say. Now, you see that we can convert this into a stick model like this, where these sticks are denoting the lateral stiffness. Maybe the structure would have 4-5 bays and a number of columns. But the summation of the lateral stiffness of columns uh, are added, and these are represented by a stick, by a single stick. That we feel much more comfortable with this kind of model, and we can the structure becomes very easily visualizable and very easily proceed with the computation. So in that case, what should is let me repeat it, that any ijth of the mass Mij, how can that in numerical methods class? It is the inertia force required to be applied at ith degree of freedom to create unit acceleration at jth degree of freedom and zero acceleration at all other degrees of freedom. So now these lumped masses are not connected by any link which have masses. Therefore, what happens that as if while writing the mass matrix, if I just look at the mass, then there is a mass here, there is a mass here, and then at the top there is another mass. So these three are disconnected. There is no even a very thin connection through any mass element. That means there are three discrete mass. We have forgotten about the presence of anything else, stiffness or damping, anything. So, so it was made humped. So actually it should be lumped. So these masses are lumped along different translational degrees of freedom, and there is no connection through the mass between the lumped masses, and so acceleration of one lumped mass doesn't affect the other. That means there is no coupling. Okay. So if there would have been coupling, then these off-diagonal terms would have come. Otherwise, so if we consider a consistent mass matrix, because this is not possible, actually there should be a link of mass. In columns are also having masses. So if we would have considering those effects, then these off-diagonal terms would not have been completely zero. Rather, they would have been non-zero. But of course, the numbers, the values would have been much lesser as compared to the to this value of the elements are diagonal, and therefore it is a kind of good approximation which is being practiced very widely. And so the lumped mass matrix comes to be this 8 into 10 to the power 5, then 0 0 again 0 8 into 10 to the power 5, and 0 0 5 into 10 to the power 5.